So we're week 7, but we're lecture 6. So last week was the time to catch up with your exercises. And I'm not sure who looked at Swirl, but it was also the time to perhaps look a little bit at yourself and how to do more advanced things and like how to use a Swirl to do those type of things. So within R, there's also, because I will only give you the highlights, so to speak, and there's lots of other things which I won't cover. And there's ways to teach yourself in a dynamic programming way where it moves along. So have a look at Swirl, and then there's some things in there about programming and some things to do with psychology as well. So last lecture we covered moderation effects. So we covered two-way ANOVAs, and today it's all about mediation. So the goals of today is to get you to draw some pretty diagrams, and also I'm going to talk to you about mediation, and there's many different ways again in R to achieve the same goals. Some of you remember at ANOVA there was like 3 different ways in which we could do an ANOVA. Similar in R, there's multiple ways to do mediation. And today we'll just do the standard ways in which we can do mediation, and then a couple of weeks down the line we'll use structural equation models to also do mediation, and then you might be able to get some further insight and see how those things work. So after today we're already on to assignment 2. So you're able to do the following sections from your assignment 2. You're able to do mediation, Sobol Z, Imai, Kili, Limit, and I'll start uploading the files for assignment 2 over the next couple of weeks. I presume you're all still working on assignment 1, but if you really urgently want to start working on assignment 2, drop me a line and I'll speed up that process. But I thought in the interest of getting things gradually to you, but these correspond to the things for assignment 2 already. So if you wanted to, and I'll start uploading those things as well, you can start working on assignment 2 as well. So have any of you ever conducted a mediation test? Yeah? Okay. So so can you tell me what type of scenario you were using your mediation test for? What was the purpose?
I was looking at the relationship between perfectionistic automatic thoughts and psychosomatic symptoms, and if they were mediated by perceived stress and shame.
Okay. So you had 2 mediators in your mediation models. So yes, like you explained, we want to use mediations where we have some idea of a causal mechanism or something which sits in between an independent and a dependent variable, something which might explain away some of the relationships between the independent and the dependent variable. So that's where we use. So it's quite popular because the argument would be that you are able to show causal mechanisms or things which explain away relationships after you include them in your model. So scenarios, so not like last time, so moderation was all about how people's behavior, for example, might change as a function of the situation. So it was how a variable interacts with another variable to generate so that not everybody responds in the same way, for example. So people high on a trait or low on a trait will behave differently on an outcome variable. Here we're trying to understand causal chains, and we're trying to understand causal mechanisms and trying to see if they explain away some of the relationships. So that's the type of scenario which you would use, like for example, if we can explain, for example, we can explain away, for example, a gender difference in ability due to achievement goals or something. So that would be a mediating variable. Yeah? So scenarios where we're looking for a causal mechanism which explains away the relationship between an independent and dependent variable. So it's grown out of path models, and the idea is, for example, we have a relationship between A and C, and then as you put perceived stress or shame, was that those would be the things in between which sort of explain away the relationship between A and C. So that's the logic behind these mediation models. You might be especially interested, so suppose in the beginning we find a highly statistically significant and strong relationship between A and C, but after we include this, there is no longer a relationship between A and C. Then psychologists are especially quite interested in those scenarios because the rationale is that we would have them fully explained away why A is related to C because it's due to this thing in the middle, which is B. Yeah. So that's the purpose of why we want to do mediation models. So some history all the way. So if you know something about biology, Sewell Wright is one of the people who discovered or was one of the founders of the coefficient of relatedness. And it dates all the way back to 1921. And basically you can think of them as regressions chained together. So it's everything, again, is regression, or ANOVA if you prefer ANOVA, but everything is OLS regressions. OLS means ordinary least squares regression, so that's the regressions you have been doing and you've done before. And we can divide the contribution of each of the coefficients to a direct contribution, an indirect contribution, and a total contribution. And total is nothing more than the sum of the direct and the indirect effect. Yeah. And so, and I won't go through all of these, but all the regular assumptions of ordinary least squares regressions apply. So normally for every regression model, you would check all those 4 assumptions that you recall, which we tested with plots, we tested with the Durbin-Watson tests, we tested all those assumptions. That's what you should be doing, but for the purpose of you teaching you mediation today, I won't go through all those assumption checks today. Yeah. So you can't have any loops. So if we go back to the scenario, C cannot feed back into A because so you can't. If you draw your diagrams, there can be no loops backwards because then we cannot explain or fit this model. So it's really to do with a scenario where everything can be chained together in one link, and you can only run through the diagram in one possible way and not in many possible ways. So there is no way to loop around it, or there is no way in which you could possibly get the coefficients in a different setup. Does that make sense? So you can only walk through this diagram in one way from left to right, and there's no way to loop back, for example. That would be the case. And more advanced things, which I won't cover, but I'm quite fond of as well, is like technically this is all graph theory, so this is all to do with social networks. And basically these are visual models which are known as directed acyclic graphs. So if you want to find out more, you can look at DAGs, and they're directed acyclic graphs, and there's an entire set of maths behind it, an entire set of statistics behind it, which deals with causality and with how to work through directed acyclic graphs and how to solve those models. So I've been talking a lot about causal mechanisms. So what do you think? Are these things really causal or not? So do you think that if you put something in a regression that instead of causal mechanism, so we can draw this model, we can do a series of regressions, and then we can check if the coefficients drop. So it's been argued to be causal modeling. So do you think this is causal or not? I know it's very difficult to interact with me, but any just raise your hand if you think it is really causal. Nobody raises their hand, so I've already given away with Tommy Moses, but what you should bear in mind when you did your study, it was all survey-based, I assume, right? So in that case, in the end, it's all correlational. So there is no experimental manipulation. So in that sense, it's not causal in the sense that there could be something which co-varies with all your measures in your survey. It's all correlational data, so we cannot say one is causal and the other one is one is causal. So if we think back to your model, we could have taken the mediator and put it in the front, have it had the IV, and have the pat run the other way, right? There's no reason why we wouldn't be able to do that. So that's all correlational. There might be cases where that's not possible, because, for example, one is a hard variable, so it's very improbable, like a very strong biological variable. It would be very implausible that a variable, for example, would influence that somewhere further down the chain. So people would tend to put some of these biological variables earlier, but again, it could be that there's a causal mechanism or a hidden mechanism which explains the relationship between both. Now, if it's longitudinal, so if you had collected something at wave 1 and wave 2, then we have a better case for causality, because it's unlikely, unless you have a time traveling machine, that something from the future would have influenced something from the past. But it's still possible, for example, if you didn't measure things properly, or there's some type of error associated over the 2 time waves, that you would still have assumed causality where there is no causality. So some people have very strong views on this, and they would say you would only do these mediation models when you're able to experimentally manipulate the mediator. So only if you're able to, so in your scenario, only if you're able to manipulate perceived stress, then they would say it's a causal model, or then they would say mediation models are appropriate. But that doesn't mean that in many other cases people have also used this with survey data, with all sorts of other data, but I have to tell you that some people have very strong views and say you should only ever do these models when you manipulate the mediators, and some people are much more lenient and they say it can work with any type of survey data. So the issue that I've just pointed out is hidden confounders. So in your example of your survey, if there was something which you didn't measure or didn't control for in your model, that could explain both the independent variable and the mediator, for example, and then you would draw a false inference saying something is causal. whereas in reality, it's not. Also, the choice of arrows, we talked about it. In correlational studies, you might have quite a lot of choices to which one becomes the independent and which one becomes the mediator. So that's all bit down to theory. And you could sort of jumble your theories until you get sort of the nice sets that you want, which is not suggesting what you should be doing, but it's what sometimes people do. So sometimes they first collect the data and then they have a little look, and then they rearrange the arrows until they get something which looks nice and fits the model which they then talk about. And I've talked about the fact that some people hold very strong views and say only if you're able to experimentally manipulate the mediator are you able to use this type of model. So they're not useful for correlational models or survey data, only when you're able to manipulate this. Now this is the intermezzo. Like lots of you might love PowerPoint. I have a strong distaste for PowerPoint, but I'm going to show you all, like, by now I should have convinced you that R can do anything. So also for your blogging exercise, R can build your website. You can do everything with it if you look at spend enough time doing it. But you can also make diagrams in it. And I'm going to show you a little bit because one of the ways to visualize this, so would be drawing, you might have drawn these diagrams in PowerPoint with arrows. Unlike, because we now have a chain of regressions, there is no straightforward one graph which we can use. So we can't use one scatter plot because we have a series of regressions. So it'd be having to show like how the regression line changes over a series of scatter plots, which becomes quite difficult to do because then we either have to have an animated graph or a panel of graphs. So when these models are typically represented, we draw the arrows and we draw the relationships that we like to find. So here's an example, and this is how we draw a graph in Diagrammer. There's all sorts of graphs, and this is known as a mermaid diagram. And so in every single thing we say what this is the label that it's using. And so it's basically a series of arrows, and we say what is connected to what. And then we say what the level is behind this. And if you're smart and you know a little bit of HTML, you know that this is HTML to sort of break up things and put in space. And so this is sort of what it would then look like. So you would have age has an effect on fertility, but it has an effect on retaining placenta, this medical thing, cystic ovarian disease, and ultimately affecting fertility. But it also affects metritis, which also affects cystic ovarian disease, which also affects fertility. So in such a way, you could visualize, so this is an example from medicine, which I just stole. I don't know anything specifically about cystic ovarian disease. But in principle, you could draw any of your theoretical models that you have in psychology. These causal models as this type of arrow diagram, right? We can make it more beautiful if we want. So we can make, we can use this type of code from GridViz. So we can change, for example, the colors. We can change the arrowheads. We can change whether it goes from left to right, from top to down. So I'm not going to run through all the possible codes, but just again give you an example. And if you want to use this, you're going to have to practice in the exercises or find out on your own. So this is then sort of a nicer graph, perhaps, because well, I think it's nicer because it looks somewhat cleaner. But you can basically change any aspect of the graph. You can see now these things are at the top rather than at the bottom, and you can see also that the arrows are slightly prettier. You can change all the fonts if you like Comic Sans for some reason. You can change whatever you want in this these type of graphs. Yeah. So you can check the Diagrammer tutorial. So there's a tutorial, and it when you go and look for this package, and it can make all sorts of flowcharts. So if you ever have to make a flowchart or a diagram, this is again something which you can do in R. You might say, why am I bothering to do this in R if I can do it in PowerPoint? If you have to do this 100 times or 200 times over your career, it will have been worth it to learn it in R, especially if it's a repetitive, time-consuming task where you have to drag and drop all sorts of things. This could be something you can use. So back to mediation. So again, I'll highlight there are differing views. Some argue that mediation is only ever useful when you experimentally manipulate the mediator. And you also have to be aware of the sequencing. If you propose something to be a mediator, then ideally it should be measured after your IV. So I'm not sure if that was the same in your questionnaire, but it seems illogical to have something which is a mediator being measured before you measured your independent variable. So hopefully the logical order in your questionnaire will be first the independent variable, then the mediator, then the dependent variable. So if you propose complex chains, then you also need to consider the temporal order of A, B, C, D. So if you have like a complex questionnaire, on the one hand you could say, I'm going to randomize all these chunks. But if you're following this mediation design, then they should be in the logical order in which you draw your causal chart, right? Because ideally you don't want things from the future to affect things from the past. So because that would affect your estimation and your logic, yeah? So these are simulated data, and it's a relationship between grades and happiness, and we can propose that it's mediated by self-esteem, for example. So if I get good grades, then my self-esteem goes up, and then I report more happiness. So that could be a sensible model. And so in this case, I download some fake data from this example from this link, and I just use D because it's a very, very long string. And in order to save some space, so you can see it's very long. So that's why I call it D, and then I just call it data underscore met to override that object to have something with a more sensible name. Yeah. Okay, so the first way in which we can do mediation is one of the oldest ways, which is we might have come across, which is Barron and Kenny, and this is known as a causal steps approach. So if you read in your literature example that they use the causal steps approach, they will have used the Barron and Kenny method, and hopefully they'll have a citation to that Barron and Kenny 1986 paper. And so they say there's 3 steps which you need to demonstrate the existence of mediation. You have to first demonstrate a relationship between your independent and your dependent. You have to show a relationship between your independent and your mediator. And you have to show that if you combine these both, that they also affect your dependent. Yeah? So that if you have your independent and your mediator in a regression, that it affects your dependent. You can read more there. And as an aside, this has 71,000 citations in Scholar Google. So it's a very popular method, or it has been a very popular method in psychology. So even though it's an older method, it remains quite popular. I'll tell you some of the issues with these methods a little bit later on, but you have to know about it, and sometimes it might just do the job for you. So this is the first step. There should be a relationship between x and y, and the regression coefficient should be significant. So that's just this. Yeah, so this is a simple regression as you've done before. So just regressing x and y. So this is what it would look like. Y, x, our data, and this model. And so in this case, we can see we have a highly significant effect of x. Yeah. So that's the first step. Yeah. So we've demonstrated there's a relationship between our independent and our dependent variable between x and y. Now, there's some controversy about this. So according to Barron and Kenny, if this step is not significant, then there can be no mediation, and you should stop here. And so you should no longer do any mediation analysis. However, other scholars say you could still move on and do the next step, step 2 and step 3, if there is a solid theoretical rationale for why there should be a relationship between x and y, and it has to do with complex things such as suppression of relationships and all sorts of other things. But you can check this link as to what their argument is to still continue with step 2 and step 3, even though step 1 is not significant. So basically, it's possible that some type of suppression effect is happening and that the mediator is so strong that it's suppressing the relationship between x and y. That's the theoretical argument behind it. So if you have a very strong rationale that grades should be related to happiness, even though you don't find relationship, then according to some people, you could still progress even though this first step wasn't significant. Any questions so far? So all we have done in this first step is do one single regression and test it for the significance of the coefficients. Now step 2, the independent variable should also relate to the mediator. If not, then there can't be any mediation because it has to run by this. Like if we have this causal path, it has to run by this mediating variable. So if this doesn't exist, then theoretically there can't be any mediation. Yeah. So we also find, obviously because it's simulated data and we set it up this way, obviously we also find support for this. You can see a highly significant effect, and you see that x predicts m. Yeah. So again, it's a regression. But this time, we're regressing our independent on the mediator. Yeah. Now, the rationale is that the effect of x should be reduced when we include the mediator in our model. So the b, so that coefficient that we have here, so this estimate should drop once we add our mediator to the mix. Yeah. So that's the rationale behind it. So now we're going to have a model which has both x and m predicting y. Everybody still with me? If I'm going too fast, tell me to slow down. So this is what it looks like. Again, these are regressions which you've seen before. Nothing new. All we're doing now is we take a series of regressions and we chain them together. That's all that we're doing. And you can see already, so we have a significant effect for our mediator. Our x is no longer significant. And if you look at the coefficient, it's also a fraction of the size that we had before. So this is 0.04. And before, if we go back, we had 0.4. So it's so it's only a tenth of its size after we've included the mediator. So went from 0.4 to 0.04. Yeah. And it's dropped out of significance. So this was highly significant, and the other one wasn't. Yeah. So after we add our mediator to the mix, we see that x no longer holds any influence on y. Yeah. So the coefficients dropped from 0.39 to 0.04. I said 0.4 due to rounding. So it also dropped out of significance. But is this significant in itself? Because suppose it had been p is 0.08 and you had a highly significant before. So where do you draw the line? Whether this drop of significance from 0.39 to 0.04, whether that's a significant drop as well. Because now we're just comparing the p-value from one model to the p-value from another model. Yeah. So we will return to this also when we discuss sum, because we can test in a formalized way how what happens if we include or exclude that path to model fit. But for now, we're going to do this in a different way, and I'm going to talk to you about that in a little bit later. But for now, it's dropped out of significance, and that's you have like it's only a tenth of its size. So intuitively, we'd say this is quite a big change after we've included our mediator. But I'll give you some examples how to formally test it. So how would you report this? So this is another example. This is not the x and y example. So you would then see, I'm not sure if you've also drawn this type of diagram. It will be this type of arrow diagram. You would say these are all the regression coefficients, and this would be the regression coefficients after you've included that one. So this is the original one, and this is how much it has dropped between brackets. That's typically how psychologists report it. I'm not saying this is the best possible way to report it, but this is typically how it gets reported, and you might have come across these type of diagrams also when reading your literature on causal or mediation effects. Yeah, and so in this case, you should bear in mind, for our models, we used B's and not betas. People typically report the betas, so the standardized coefficients. If you go back to regression, I've shown you how to calculate standardized coefficients. Is basically you standardize everything, you drop the intercept from the model, and then you run your regression again. But for our model, we use the absolute coefficients, the unstandardized coefficients, to look at. So now, first we're going to try it yourself. You're going to download the dataset, and we're going to go through these 3 steps. And so in this case, we're going to have, you can right-click, and then you should save to your file. You're going to do the 3 steps, so step 1, step 2, step 3. With math as the independent variable, read as the mediator, and science as the outcome variable. And so don't bother too much about the rationale behind this study, but it's just an example. So go through the 3 steps which you have had before. Okay.